Welcome. What I want to do in this video is talk about some misconceptions of operations of functions. And the way that I'm going to do that is I'm going to look at four statements that are false and work to provide a counterexample to kind of show you, why they are going to be false. So in the first example, I have number one, when combining two functions, you determine the domain by including the union for domains from both functions. And it's actually when you're looking at combining, which would be adding and subtracting, you're actually not finding the union of the two domains. You are actually finding the intersection of the two domains. So for instance, if I had like f of x equals, square root of x, and my other one was f of x is equal to, x, let's say. So this function is restricted to all positive numbers, right? So from 0 to infinity, but x is defined for all real numbers. So the union of these two functions would be all real numbers because you're just adding them together. Even though they're not both defined for negative numbers, since one of them is defined, that would be within the union. But the intersection is only going to be the domain where they are both true. So you could see the intersection of these two domains would only be from 0 to infinity. The domain from the quotient of functions is equal to the product, and that is not true. And it doesn't matter what your functions are, not equals to, but if you have two functions, f of x, and you're multiplying them times g of x, okay, that's fine. If you have domain restrictions, again, you're finding the intersection. But when we deal with division, it doesn't matter which one you're doing, f of x or g of x in the denominator. The main important thing is that you have g of x in the denominator. So now sometimes, actually I should have probably clarified this question. Sometimes they can be equal depending on what the function is for g of x. So I should have said it's always equal because it's not always equal. For instance, if I said f of x was, equal to, x plus 2 and g of x was equal to 2x. All right. So obviously when you multiply them, the domain is going to be all real numbers. But when I divide by them, since 2x is now in the denominator, x cannot equal 0. So the domain is being restricted for the quotient because you're placing a function in the denominator. So it's not the same as multiplication, and it's also not the same as multiplication, addition, and subtraction. So we got to be careful with that. It could be the same, but it's not always going to be the same. I should say is always equal to the product of two functions. All right, the next one is the domain from composition of two functions does not depend on order of composition. So the domain, so we're talking about the domain, and that kind of makes sense. Like if you look at f of x equals like x plus 2, and again, same thing, f of x equals 2x. Like obviously the composition, one plugging one into the other is going to give you different functions, right? So if you plug g of x into f of x and f of x into g of x, you're going to get different values. But the domain is still going to be all real numbers. It doesn't matter which one you do it. But is that true for all functions? And that is not true for all functions. Because if I change these functions for like f of x equals, let's say the square root of x, and g of x equals x squared, well, when I plug g of x into f of x, so I have f of g of x, I get the square root of x squared. And the important thing here is the order. When you're finding the domain of composition, you have to make sure you take into account what the domain is of the function that you are inserting into the other function. And you can see here that I'm inserting into the function x squared. So that domain is unrestricted. So the domain here would be negative infinity to infinity. Whereas when I do g of f of x and I plug f of x function into the g of x function, I now have square root of x squared. And the domain restriction of square root of x is from 0 to infinity. So the order does matter because here, you can see these are both unrestricted domains, so it didn't matter which order I was plugging them in, right? But once you have a restriction on your domain, the order matters on far as which function you're plugging into the other function. And then obviously the domain of the restrictions is going to be, from what function you're plugging in as well as the composition together. But I'm going to kind of get more into that composition together in this next example. The next example says the domain from the composition of the two function is determined from the simplified result. Let's go ahead and use these two examples again. F of x equals the square root of x g of x equals x squared. So when you apply f of g of x, you have the square root of x squared, which is just going to simplify to x, right? And when you do g of f of x, you have the square root of x squared, which again just simplifies to x, right? So the simplifying is going to give us, and you might think, well, oh, these are all real numbers, right? Because they both simplify to x. But if you go back to our previous statement, you got to remember what function you plugged into the other function is going to stay with that function. So the domain of this composition is negative infinity to infinity, whereas this domain, even though it gets simplified to x, remains 0 to infinity. So those are some of the misconceptions that I came up for operations of functions. I would love to kind of hear what maybe misconceptions you have or that maybe you thought of that you think would be great to kind of add to this list. So if you have any misconceptions that you want to add, please feel free to add them to the comments. I can't wait to kind of see what you guys come up with. Cheers.